All my dear students, Assalamu alaikum. My name is Iftikhar Hussain and I have the experience of teaching the local and international boards. Through this platform of Academy of Excellence, I will try to teach you the topics based on more conceptual understanding, more detailed and more applicable way. Today, the topic that we are going to discuss is the mechanics, and in mechanics, our subtopic to discuss is momentum and impulse. My dear students, tell me one thing. Have you ever seen light? कभी आपने लाइट पे गौर किया हो तो लाइट की स्पीड दुनिया में सबसे फास्टेस्ट स्पीड है. And when it falls on your face or on your body, does it make any impact on you? No. Does it give any force to you? No. Similarly, if we see an example, अगर हम एक और सिनेरियो को देखें, एक ऐसा ट्रक जिसका मास बहुत ज़्यादा है और आप उसके सामने खड़े हैं, क्या वो आपको इम्पैक्ट करता है? क्या वो आप पे फोर्स अप्लाई करता है? The answer is no. Then एक छोटी सी बुलेट आप पे इतना बड़ा इम्पैक्ट क्रिएट करती है, and that's something very strange. In the first case, when we talk about light doesn't have any mass, so it doesn't impact you. Similarly, in the second case, when we talk about a very big truck जिसका मास बहुत ज़्यादा है, वो आप पे इम्पैक्ट नहीं कर रहा बिकॉज उसके अंदर कोई वेलोसिटी नहीं है. In a nutshell, यानी अगर हम इस बात को गौर से देखें तो दो चीज़ें हैं जो कि किसी भी बॉडी के अंदर क्वांटिटी ऑफ मोशन के लिए रिस्पॉन्सिबल हैं. नंबर 1 इसका मास एंड नंबर 2 द वेलोसिटी. These are the major factors which are responsible for the total quantity of a motion in the body. Quantity of a motion in the body? Yes, that's the total impact. So our topic to discuss is momentum. And from this discussion, we are concluding that the momentum depends upon mass and the velocity of the body. As discussed right now, it means momentum of the body depends on mass and velocity, and that is basically its actual definition. Linear momentum is defined as the product of its object's mass and its velocity. It's defined as P is equals to m times v. M is the mass of the body and v is the velocity of the body. So unit is kg meter per second square, kg meter per second. Now it's a very simple question that is given to you. You have a bullet whose mass is 4 gram and it has a speed of 950 meter per second. So what's going to be the momentum? We discussed that momentum is given by mass times velocity. Its mass is 4 gram and the velocity is 950 meter per second. The momentum is going to be mass times velocity. But remember, the mass should be in SI unit, that is kilograms. So it's going to be 0.04 times 950, which is equals to 3.8 kilograms meter per second. The quantity of the motion that exists in this bullet is 3.8 kilograms meter per second. Now let's discuss the relationship between momentum and the net force that you apply. We know that from Newton's second law, as the topic is also Newton's second law in terms of momentum, the formula for force is mass times the acceleration. The value of acceleration is the change in velocity per unit time, and if you multiply mass with velocity, that is going to be m delta v over delta t, or mass into change in velocity is change in momentum. So we conclude that the net force is equals to change in momentum over time. So it can be concluded from the Newton's second law that the net force that you apply on a body that creates a change in momentum. अगर आपके पास एक ऑब्जेक्ट है जिस पर आप फोर्स अप्लाई करते हैं, जब आप फोर्स अप्लाई करेंगे इनिशियली बॉडी का, लेट्स सपोज इनिशियली बॉडी की जो वेलोसिटी है दैट इज 0. आपने फोर्स अप्लाई की, उस फोर्स के इम्पैक्ट की वजह से उसकी वेलोसिटी चेंज हो जाएगी. जब वेलोसिटी चेंज हो जाएगी, मास बॉडी का कांस्टेंट है. जब बॉडी का मास कांस्टेंट है तो इनिशियल मोमेंटम इज mvi एंड द फाइनल मोमेंटम इज mvf. द चेंज मोमेंटम इज mvf माइनस mvi over delta t. So we can conclude that net force is equals to change in momentum over the time. It's very simple. अगर हम एक एग्जाम्पल देखें, आपके पास एक ऑब्जेक्ट है. An object increases speed from 5 meter per second to 25 meter per second in 30 seconds. What is the net force acting on it? So it means you have applied a force in order to change its velocity from 5 meter per second to 25 meter per second in 30 seconds. So you need to calculate the force. We know that from the formula, force is mass times change in velocity over time. That's acceleration. So very simple. Mass is 6, final velocity is 25, initial velocity is 5, over change in time is 30. Then the net force is going to be 4 Newton. अगर आप सिंध बोर्ड की बुक में एक एंड ऑफ एग्जाम्पल का क्वेश्चन देखें, सेम इसी सिनेरियो पे आपके पास एक न्यूमेरिकल भी गिवन है जिसमें एक गन से 10 बुलेट फायर होती हैं इन सम स्पेसिफिक टाइम एंड दे हैव गिवन यू द फाइनल वेलोसिटी फॉर दैट. तो हाउ डू यू फाइंड द फोर्स नेसेसरी टू होल्ड दैट गन? You simply multiply the mass with change in velocity over time. You will get the force to hold the gun in order to keep it necessary. Now, what happens? A collision. For example, if I have two hands, if I collide them, this is a collision. Collision is an interaction of two bodies when they collide together. Either there could be a bang, एक धमाका, या कोई टकराव, कुछ भी हो सकता है. एक एग्जाम्पल है आगे पास. This is the example. An asteroid strike the Earth's surface, and due to that collision, there is a very big hole. And similarly, there are collisions in the space in which planets collide together. Now, discussing about before going toward the collisions and the other factors, my dear students, हम लोग इलास्टिक कोलिजन्स या कोलिजन्स लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम पे जाने से पहले मैं आपको कुछ एक सॉफ्टवेयर के थ्रू एक वीडियो दिखाना चाहता हूँ जिसके ज़रिए से आप इस चीज़ को एनालाइज करेंगे कि वेलोसिटी का इम्पैक्ट कैसे चेंज होता है, कैसे एक बॉडी दूसरे बॉडी में अपना मोमेंटम ट्रांसफ़र करती है. इस सिम बकेट सिमुलेशन में अगर आप देखेंगे कि आपके पास एक बॉडी है जिसका पहले एक बॉडी का मास 3 किलोग्राम है, जिसकी इनिशियल वेलोसिटी मैंने 8 मीटर पर सेकेंड रखी है. दूसरी बॉडी का मास 1 किलोग्राम है और जिसकी वेलोसिटी 4 मीटर पर सेकेंड है. अगर मैं आपसे बोलूँ पहली बॉडी का मोमेंटम क्या होगा, व्हाट्स गोइंग टू बी द मोमेंटम ऑफ द फर्स्ट बॉडी, दैट शुड क्लिक इन योर माइंड दैट इज गोइंग टू बी 8 times 3, दैट इज 24 kg मीटर पर सेकेंड. फॉर सेकेंड बॉडी इज गोइंग टू बी 4 times 1, 4 मीटर पर सेकेंड. ओके, नाउ व्हाट अबाउट द टोटल मोमेंटम बिफोर एनीथिंग या बिफोर कोलिजन? It's going to be 24 plus 4, that is 28 meter per kg meter per second. Okay, now if we see the initial velocity of the body A, that is 8 meter per second, and the initial velocity of the body B is 4 meter per second, what comes in your mind? Definitely, what you are thinking is the right one. The body A is going to collide with body B. Okay, let's start. I'm going to give it a thought. Oh my god, there was a collision, and after the collision, the velocity has been changed. So what you analyze? The velocity of the body A is being changed from 8 to 6, and for the velocity of the body B is changed from 4 to 10. That's a good big change. The velocity of the body B is increased while the velocity of the body A has been decreased. Okay, fine with that. Now if I find out the total momentum after the collision, so what's going to be the value? 6 times 3, that's going to be 18, and 10 times 1, that's 10. 18 plus 10, that's 28. Before it was also 28, and now it's also 28. So it means that we conclude that the total momentum before and the total momentum after the collision is always going to be the same. That's a very strange result. And that result we can also predict from a conceptual understanding of law of conservation of energy that says that the energy before is always equal to the energy after. That's the same concept. Alright student, now from the previous simulation आपने एक चीज़ एनालाइज की कि the total momentum collision से पहले and collision के बाद is always going to be the same. Now one thing that we have already discussed, impulse. इम्पल्स को थोड़ा सा और जानने की कोशिश करते हैं कि इम्पल्स का इम्पैक्ट क्या है और इम्पल्स है क्या चीज़. अगर आपके पास दो बॉडीज जिसका सेम मास है और दोनों को मैं अगर ड्रॉप करूं और पहली बॉडी आके डायरेक्ट सरफेस को स्ट्राइक करे और रुक जाए, दूसरी बॉडी आए सरफेस पे स्ट्राइक करे एंड इट गिव्स अ जंप बम्प्स एंड देन कम्स टू स्टॉप. Now if I ask you which body has greater impact, so that is going to be the body A, which strike, जिसने strike किया और force ज़्यादा impact की, time बहुत कम है. यहाँ force का impact larger time के लिए लगता है. But change in momentum here and the change in momentum here is going to be the same because सबका mass same है और velocity same है. लेकिन इस केस में body का mass, body की force ज़्यादा है, इस केस में body का force कम है. टाइम यहाँ ज़्यादा है, टाइम यहाँ कम है, दोनों का प्रोडक्ट सेम क्वांटिटी देगा. तो इम्पल्स इज बेसिकली फोर्स टाइम्स द टाइम, F मल्टीप्लाई बाय डेल्टा T, विच इज इक्वल टू चेंज इन मोमेंटम. बॉडी में कितना मोमेंटम चेंज आया है. इसको डिस्क्राइब करते हुए हम दोबारा मोमेंटम को इम्पल्स से रिलेट करेंगे. आई गिव एन एग्जांपल. एक बॉडी आई, दूसरी बॉडी ने कोलाइड किया. जब दूसरी बॉडी ने कोलाइड किया, दिस इज the scenario before phase, this is the collision phase, and this is after the collision. Now the system boundary is an area of interest used by physicists to in the study of the complex processes. Now this is system boundary, and system boundary. In system boundary we are talking about a momentum system. Now conservation of momentum. Before studying the conservation of momentum, we were having two bodies. His mass was m1 and the other mass was m2. His initial velocity is, body A has the initial velocity of v1i and body B has a mass of m2 and his initial velocity is v2i. Now both bodies collide together and after collision its velocity changes to v2f and body A's final velocity changes to v1f. So what's going to be the impulse by the body B on body 1? It means body A strikes with body B. How much impulse is going to be transferred from body B on body A? अभी भी हम लोगों ने डिस्कस किया, impulse जो होता है that is equals to change in momentum. Now force on by body 2 on body 1 times delta T is equals to change in momentum. Okay, what is change in momentum? That's going to be final momentum minus initial momentum. Fine. So what's going to be the initial momentum? This is going to be m1 v1f minus m1 v1 vi. Final momentum of the body 1 minus the final momentum of body, initial momentum of body 1. Okay, then we have a collision, and after the collision we know that impulse by body 2 by on 1 and the impulse on body 1 by 2 is always going to be the same as per Newton's second law, and action and reactions are equal in magnitude but opposite in direction. So that is going to be for body 2. Its final momentum is m2 vf2 minus m2 vi1. Okay, now here comes the third law of Newton. The impulse by body A on B or the impulse by body B on A is going to be same but different magnitude, but different in direction. So m1 v1f minus m1 v1 vi minus m2 v2f minus m2 v2 vi. If I change the sign and equate them, that is equals to m1 v1i plus m2 v2i is equals to m1 v1f plus m2 v1f. That means this is the total momentum after collision and this is the total momentum before collision. This is the same as we have discussed in the video that we have already watched, that whenever there is going to be a collision, the total momentum before and the total momentum after is always going to be the same. So my dear students, I hope you have understood some of the basics regarding momentum. The further description is going to be given in the next video. Thank you for watching the video.